Large language models are incredibly powerful, but they have one major flaw. They don't have access to recent or external knowledge. Their training data has a cutoff date, meaning they can't answer questions about recent events or newly released technologies. To demonstrate this, we will use a model from Ollama and ask it a question about a recent event that's after its cutoff date. We'll see that the response it gives will be incorrect. To fix this, we will use Retrieval-Augmented Generation to provide the model with relevant and factual information which it doesn't have access to. But before we get started, this tutorial will be using Ollama. If you don't have Ollama installed, I recommend you watch my AI Engineering for Beginners video. Once you have that installed, we'll get started. Okay, so the first thing we're going to do is open up a terminal within VS Code, and we will download the model that we'll need to use for this. And the model that we will be using, so first Ollama pool, is Llama 3.2, and then the 1 billion parameter model, as it's the most lightweight model available. I've already got installed, so worked instantly, but you might take a few minutes. So next thing we'll do is set up our old Python environment. So we'll create a virtual environment with python-m venv, then we will call the virtual environment venv, and this will allow us to install packages only for this project, so it doesn't interfere with any other Python projects or scripts you're trying to run. So with that virtual environment created, we'll now need to enter into it, which we can do with going into venv scripts and then activate, and we can see with the venv there, we are now within the virtual environment. So now we need to install a few packages. So there's quite a few we need to install. So we'll start off with Ollama. Next will be LangChain. Next will be LangChain _ community. Next is LangChain -Ollama. Make sure you've got underscore for the community one and dash for the Ollama one. We then will add PyPDF, and finally ChromaDB. So there's quite a lot of packages that we need to install with this, so it may take you a few minutes, but we'll come back when that's done. Okay, so we now have all those packages installed. What we're going to do to begin with is give a prompt to the LLM asking it when its cutoff date is. We'll see the date of when it last had any new data added into it, which would mean anything that happened after that date it does not have access to. So we are going to create an app.py file, and we're going to do very bare bones thing, which is just to have the ability to write a prompt to the LLM without using RAG. So initially the only thing we will need to import is from LangChain Ollama, import chat Ollama. So that's all we'll need to begin with. So now let's create a new function, which will be prompt without RAG. This will take a prompt, and this will be set up so RAG is not involved. So we'll first create an LLM object using the chat Ollama, and inside of here we need to specify what model we are using, and that is Llama 3.2 with 1 billion parameters. So with that, we are now going to send our prompt to the LLM and get response from it. So the response is equal to llm.invoke, and we are going to make our input a list where the first message comes from the user, and the message that the user sent into the LLM will be the prompt. So with this message we will now return the response, but within the response we'll return the content of it. So when we run this function, we'll pass it a prompt, and we are going to in return receive the message back from the LLM. So to see when the cutoff date was, we're just going to write a prompt to it asking it when it was. So let's do print prompt without RAG, and the message we will send it is, what is your cutoff date? And if we run that, the LLM should tell us when its cutoff date was. So we will now run it with Python and app.py, and it says my knowledge cutoff is currently December 2023. So that means any event that happened after December 2023, it has no knowledge of. So to test this, we will ask it about an event or a technology that happened afterwards and see what type of response it gives us. So something recently, which is new within the world of AI, OpenAI released a deep research tool within ChatGPT. So we can ask it, or I guess tell it, explain to me in detail what OpenAI deep research is. So we will have that as our message, as our prompt, and we will see what the LLM will give us in return. Okay, it's given us a response, so let's see what it says. OpenAI Deep Learning Research is a research division of OpenAI, the company behind the popular AI chatbot language model, ChatGPT. While ODRL is not directly involved with generating text or answering questions like ChatGPT, it plays an important role in developing and applying advanced deep learning techniques to various computer vision and natural language processing problems. So as it said, deep learning research is a research division of OpenAI, which is not correct, as deep research is a specific product within ChatGPT which allows you to use ChatGPT to do in-depth research of a topic. So it's an actual product, not a team or division within OpenAI. So if we did want to find out more about OpenAI deep research through our LLM, well, we can't do that currently because it doesn't have that information. But that's where RAG comes into play, Retrieval-Augmented Generation. The way that RAG works is that you have information about the topic you want to talk about, and you specifically look through that information and provide it to the LLM, which along with your prompt, to get a better understanding of it. So with this statement that we gave to it, or request, explain to me in detail what OpenAI Deep Research is, we would include along with it information about Open Deep Research, and we'll use that information to explain it to us. So I guess another way is, how do we actually provide this information to the LLM? So the way that RAG works is you have a specific data store. It could be a database of some kind. The most common way that people do it now is they use a vector database. And a vector database, unlike traditional databases like Postgres or SQLite, is that they store vectors within it. And the way that works is you have your text, you convert it into embeddings using a certain embedding model, and which, in other words, it uses vectors for that data type, and you store that within the database. And what this allows is you could write this prompt. This prompt itself gets turned into the vectorized data, and that vectorized data is used to search through the prompt for other vector information which is similar to yours. Or in other words, you might put a document within it, and it'll find the information within that document which most closely relates to the words within your prompt. So within this instance, we're going to find information relating to OpenAI Deep Research. We're going to add it to our vector database, and then when we write this prompt, it's going to first search through the vector database using our prompt. It'll retrieve the most relevant information relating to it, and then we will pass it to the LLM along with this prompt, and the LLM will be able to provide a good explanation for us. So first things first, let's go grab some information. So commonly with Retrieval-Augmented Generation, you'll use documents which you'll save within the vector database. So what we can do is we can go to a website and we can find information about OpenAI Deep Research, we can save it as a PDF, and then we add it to our vector database. So let's just do a Google search of OpenAI Deep Research. And let's go to OpenAI's website where they are introducing deep research. So we have the website here, and it has a lot of information as to what deep research is. So if we wanted to use this website, what we can do, Control P to print it, and we can use Microsoft Print to PDF to save this website as a PDF document. So we will do that. So I've navigated to our project, and I'm going to save this as OpenAI_deep_research. So save that. Okay, so that's now saved, and we should see it within our project here, like so. So we will now need to set up our prompt with RAG function, but before we do that, we will need to import a bunch of different packages for this. So we'll start off with from LangChain community .document loaders. We'll import pydf loader. So this is for reading the PDF file we've just downloaded. We will then do from LangChain.text splitter, and we will import recursive character text splitter. Oops, I just realized up here we didn't properly import it, so let me do that again. Okay, that's correct. Now what this one does, it's going to read through our whole PDF, and it's going to split up the text into chunks. So when you're actually looking through the vector database, it's going to search for specific chunks of the data within the database. So instead of it being a whole PDF file, you might split it up into 100 chunks or something, and this will be little sections within the PDF. So instead of it retrieving the whole PDF, it will only retrieve the specific section that you want. But not only that, instead of it being like a chunk and then a chunk, you're going to have overlap between the chunks, just to make sure you get the best results possible when you're searching through it. So that's what the recursive character text splitter is for. We are then going to import from LangChain.embeddings.Ollama. We will import Ollama embeddings. So what this is for is turning these chunks into the embeddings that we'll then be able to use with Ollama. And then from here, from LangChain.vectorstores, import Chroma. So this will be the actual vector database that we are using to store our vectors within. And an additional thing we'll import for helping us with our prompt, import from LangChain.prompts, import chat prompt template. This will allow us to create a template which we just embed our context from the vector store database RAG into it, and then also our prompt. So with those imports done, we will now create our prompt with RAG. And we also just pass it a prompt. So we're going to start off with loading the PDF, turning it into the chunks, creating embeddings using the Ollama embedding, and then storing it in the Chroma vector database. So to start with, we'll create a function called loader using the py PDF loader, and we will pass it the directory. So we're going to pass it the PDF file to it. So because we're in the same directory as it, we just need to do openai_deep_research.pdf. So that loads the PDF. Actually, we haven't loaded it yet. We've just created the loader which will allow us to load it. So what we'll do next is actually load it, and we'll load it into the variable pages. So we'll do loader.load. So this pages variable will now contain the PDF within it. Next, we want to create our text splitter, and we use the recursive character text splitter. Now we'll specify the chunks. So let's do your chunk size. Let's do 200, and then we will do chunk overlap, or chunk underscore overlap, and we'll do 50. So there aren't really. So I've kind of used any number here for it. Basically, each chunk is going to be 200, but between each chunk there's going to be an overlap of 50. So the first chunk will be 200 in size. The next overlap is going to go to 150 of this, so an overlap of 50, and then do the next 200, and so on. So with this, we're now going to create our chunks using the text splitter. We will then split documents, and we will pass it pages. So we now have our chunks of the PDF. Next, we are going to create our embeddings. Well, I guess this is the actual embedding itself, not the embeddings of our chunks. So using this, we will create our Ollama embeddings. And for this, we need to pass it a model, and it's going to be the same model that we're using for the LLM. It's going to use the same embeddings as it. So we'll do Ollama 3.2, and once again, 1 billion parameters. Now, we're going to set up our database for Chroma. This is straightforward, as it just saves it as a I think it saves as a SQLite database within your directory, but it's set up to store your vector embeddings. So with that, we use Chroma, and from documents, we will pass it our chunks, we will then pass it our embeddings, and then we need to set up a directory for it to save the database to, and we will just call it rag_db. So we have our database set up. What we now need to do is use our prompt to retrieve chunks from the database which are relevant to our prompt. So we will go down here, and we will do docs Chroma. And this will be using the DB Chroma. We will do similarity search with score, and we'll pass it our prompt. What this is doing, we're going to be searching through the vector data within DB Chroma. We're going to pass it our prompt. It's going to be vectorized using the same information, and it's going to use a similarity score to search the distance between our prompt and then the data within it. So the distance of the similarity score is how similar it is. So the closer the distance, the more similar it is. The further the distance, the less similar it is. So with this, of all the information we have stored in our DB Chroma vector database, we're going to retrieve the most similar information within there to our prompt. So we now have these similar chunks in our docs Chroma variable, and now we're going to create a text variable, just context text, and this is going to be the text of our docs Chroma, which we're going to then pass into the prompt to the LLM. So context, we're going to join them together based on new lines, so they're separate. And what we're going to do is build a list. So for doc and underscore in docs underscore Chroma, we are going to do doc.page content. So we've got a string which consists of all the page content that we've just retrieved using our prompt. So that's most of the RAG content done. So we've got our RAG database set up, we've retrieved it, we've stored it, and now it's about actually writing our prompt to pass to the LLM. So we'll start off with a prompt template, and we'll do 3 quotes there so we can do a multi-line string. So first, we want to pass context to the LLM. The LLM needs to know that this is context that it will use to answer our prompt. So let's start off with telling the LLM, respond to the prompt based on only the following context. So within there, we're then going to pass the context to it. And now that it has this context, answer the following prompt based on the above context. And then we'll pass it our prompt. So that is super simple. The way that RAG works, you are simply providing additional context along with your prompt. So that is essentially what RAG is. So now let's create a prompt template, which is going to be using the chat prompt template there. And we'll pass it the variable for prompt template we just created. Now with this, we're going to create a prompt using the prompt template, and we're going to format our own text into it. So first, the context. So context, which is this right here, is going to equal context. And now prompt, which is this right here, is going to equal prompt. Well, actually, I just realized it's not context. We named it context_text. So now we've got that. And now all we need to do is basically everything else that we had here. So we can just copy and paste the rest of this and put it into here. Although just noticing we have our prompt variable which is passed to this, and then I named this prompt. So let's rename this to rag prompt. So I've got a rag prompt, and that's what we're going to be passing to the LLM. So that is essentially how RAG works and how you set it up. So let's do the exact same thing, but now using the with RAG function. And just so we can clearly see the difference, let's prompt without RAG, and then we'll do the same thing below, add some new lines so we can clearly separate it, and prompt with RAG. So if I set this up correctly, we should be able to run it with python app.py, and we should not get any errors. So I've got the prompt without RAG print there. It's now passing the prompt to the LLM without the RAG context, and we should see a similar response as we had before. We have just received the response back, and we can see the response it's giving is incorrect. Deep learning research was established in 2020, which is not true because the deep research product was just released very recently. So without RAG, it's giving an incorrect response. And I've got a syntax error here. So let's see what I did wrong. This is meant to be chunk size. So we will rerun that, and I'm going to come back once we have our response which includes the RAG context. Turns out there was another error, which is single curly brace encountered in format string, which I'm not sure why, because we clearly don't. I'm not sure if this is an issue, but maybe we need to align a bit better. So we'll do that and run it again and see if that fixes it. Okay, no, I see what the mistake is. It's saying line 40, so this line actually did a mistake there. It should be dot from _template. So now it should work. Okay, so I could see from the response I got that this wasn't working, and I can see why. So in the PDF that loaded, it's not loading all the text. In the PDF, it's only loaded this at the very top here. So for every page it has, there's only that text, which we can see in the page content right here, introducing deep research, blah 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 blah. So that was the only information that was being passed to the LLM, and was causing it to give the wrong information. So I'm going to try improvise, and instead of using a PDF, we are instead going to create our own file, which will be the same thing, open AI deep research, and we'll call it .txt. And let's see if we can go in here and let's just go and copy and paste all the text that's on this page. I have no idea what this is gonna do, whether it'll work, but let's just try it. So copy that, paste that onto here. Seems to have copied it all right. Okay, so we'll save that. And let's look at changing this so it uses the text file instead. So firstly, we're not gonna need this PDF loader. So let's get rid of that. We will still need this. And instead of split document, it'll be split text. So does that just take in a string? It does. So we'll remove this from it. Let's see for Chroma from, okay, what does it return from text? Okay, it's returning this document thing, so this would then be from texts. Does this work the same way? It appears to. So what we need to do now is, with open AI deep research.txt as f. Let's do, so file text is equal to f.read, and that returns a string. So I assume we could just do this, but what I'm going to do is print file text first, just to double check, and we'll exit from there. So let's rerun this. Okay, fread is wrong, Maybe we need to specify that it's read, and then that would work. Nope, that's not working. Okay, it might be the encoding which is wrong from looking it up, so maybe we need to specify UTF-8. Okay, there we go. Now we've got all the text there. So we'll remove this print, we will rerun it. I'll go down to here and remove and re-add this back in so we can then do the comparison. But I will rerun this, and then I'll come back when this hopefully now gives a correct response. Okay, so I finally got it working. Before we look at the response that it gave, I'm going to go through the changes I had to make this work. First, I changed which embedding model we used. Earlier, I incorrectly said we were using the Llama one, so like the RAG would work with it. I was wrong. So you can use whichever embedding model you want. So this is a fast model one. To use this, you just need to do Ollama pull nomic-embed-text. So that's how you would get it working. Next thing I did was change the chunk size. So originally with 200 and then 50 overlap, you're essentially, of the text that you have, you're essentially adding an additional 25% on top of it. So it was not as efficient as it could be in terms of data storage. But the biggest change I made was removing the majority of the text we had here. We had something like 2,000 something lines, which was causing it to just break, essentially, not work at all. So I went into here and I just copied the main text from here, so like these main paragraphs. So originally all the stuff that was in these we copied over, which caused it to go to 2,000 lines. So now we've only got the main paragraph text that was within that page. So with that said, we've now got it running where we've got all this text within our vector database. We were able to use our prompt to retrieve certain chunks from it, and we were able to add that into our prompt, and we've now got a response back. So let's see. OpenAI Deep Research is a revolutionary new agent that has been introduced by the company. In simple terms, it's an AI model designed to perform complex research tasks on the internet independently. This AI, which we'll call Deep Research, uses its reasoning capabilities to gather information from various online sources and synthesize it into comprehensive reports at a level similar to that of a professional research analyst. I won't read the rest of it, but we can see now that this is accurate in terms of what OpenAI Deep Research is. With RAG and being able to supply additional context to it, which it doesn't have access to, we can now use the LLM to provide accurate responses back to us based on the prompt we have and based on the data that we give it. Although we had a few hiccups along the way, we were able to successfully create our own Retrieval-Augmented Generation system that we could use with our LLM. We were able to supply our own factual information to the RAG system, and we were able to provide that to the LLM, so we can ask it a question and we know that it's going to use factual information in its response back to us. If you like this video, make sure to like and subscribe.